do statement, and this is the syntax. We have do and then the expression, and I already log in with my credentials and MySQL. So do executes the expressions but does not return any results. In most respects, do is shorthand for select expression but has the advantage that is slightly faster when you do not care about the result. Do is useful primarily with functions that have side effects such as release underscore lag. Example, this select statement pauses but also produces a result set. So let's check it out. So what we have, we're gonna select sleep, so it's gonna be select and it's gonna be a sleep like that, and inside of the parentheses we're gonna pass in the number 5, and we're gonna end that this statement with a semicolon. So let me see, it took a while, but we have a sleep here, and then we have 0, so one row and set. Do on the other hand pauses without producing a result set. So let's try it out. So we're gonna instead of just in this example we use the select, now we're gonna use do, and this time it's gonna be asleep. And okay, so inside of the parentheses we're gonna pass in the number 5 and press enter, and let's wait a little bit. Okay, query okay. So as you can see, query okay, 0 rows affected. Okay, do and the other hand pauses without producing a result set. So as you saw, it didn't produce any result as we saw here. It produced a table when we use the select sleep. This could be useful, for example, in a store function or trigger, which prohibits statements that produce results. Do only execute in expressions. It cannot be used in all cases where the select can be used. For example, do ID from T1 is invalid because it references a table. So let's check out the next section. And the next section is the except clause. And this is the syntax. So we have the query underscore expression underscore body except, and then inside of the brackets we have all or digital operator, the distinct query underscore expression underscore body. Then we have the except, and then in brackets again we have all vertical bar distinct query underscore expression body. Then we have the query underscore expression underscore body except limits the result from the first query block to those rows which are also not found in the second row, as with union and intersect. Either query block can make use of any of the select table and values. An example using the tables A, B, and C defined in section 13.2.8 intersect clause is shown here, so you can check out this example. And we have here table A except table B. So let's so first of all you need to show databases, so databases like that, so you can check out your databases, and now you're gonna use one of those databases. So I'm gonna use the my common queries database, and now I can pretty much type in show tables like this, and I don't have the tables table A and B, so I'm gonna create those tables. So it's gonna be create table, and it's gonna be A, and we're gonna give it a name, and it's gonna be a bar chart, and it's gonna have a value of 20 like that, semicolon. And we're gonna do the same thing for table B, lowercase letter table B. So now if we type in show tables, we are gonna see that we have tables A and we also have table B. Okay, so now let's see table like this, table A except, okay, in uppercase letter, so except table, and it's gonna be lowercase letter, and we're gonna end that this statement with a semicolon. So we have table underscore letter lowercase letter A except table lowercase letter B. So we have that, and then we're gonna see an empty set, so we have nothing here. Okay, so if we go into the table A except table C, so we're gonna have an error because we don't have a table C. Okay, common query doesn't exist, so we're gonna create it. So it's gonna be create table. Okay, it's gonna be table. Let me see if I have it already here. Okay, we're just gonna put it like that, table C. like this. Okay, and okay, so we can just pretty much have this example is gonna be table A, and it's gonna be except. Okay, so it's gonna be table A except C. And now, okay, even though it's an empty set because we just created those tables, as you can see, it's working even though we have an empty set here. But that's how you do it. Now we have table B except table C, and even though they are empty, it should work anyway. It should set at least empty set. So we're gonna have table lowercase letter B except table lowercase letter C, and we have an empty set. So yeah, it's working. As with union and intersect, if neither distinct nor all is specified, the default is distinct. Distinct removes duplicates found on either side of the relation as shown here. And by the way, you can, if you can refresh your knowledge with this link and creating a table. So this is, it shows you how to create a table. So create a table, whatever the name is here, the name, you put a bar chart, all the stuff here. Then you would do show tables to see how many tables you have in your database. You can describe your table. So what is the bar chart, what is the value inside of the bar chart, and then if you want, you can insert manually, for example, values into your table. We already saw this in previous videos. And also you can load data local env file. Doing this, you can log in information from Excel, or for just I have an example here, and it was Express, no, it was MySQL. So I have an example, for example, in event.txt, something like that. You could create a file in a .txt file, or just your Excel. So you have that. And now what we are gonna see is this example, table C except distinct table A. And again, since this table is empty, let's see if it works. It's gonna be except, okay, it's gonna be now the word distinct, like that, distinct, and it's gonna be distinct table, and it's gonna be lowercase letter A. Okay, empty set, even though it has nothing, is working. Now we're gonna see table C except, and this time is gonna be, instead of the word distinct, we're gonna just have the word all. So table C, table lowercase letter C except all table lowercase letter A, and again it's working. The first statement has the same effect as table lowercase letter C except table A. Unlike union or intersect, except is not commutative. That is, the result depends on the order of the operands as shown here. So let's try it out, and let's just type it in. So it's gonna be table, okay, table lowercase letter A, and it's gonna be except table lowercase letter C. We end up with a semicolon. Okay, it's an empty set, that's fine, it's working. And finally we're gonna have the table lowercase letter C except table lowercase letter A, and again empty set, is working. As with union, the result sets to be compared must have the same number of columns. Result set columns type are also determined as for the union. Except was added for the MySQL 8.0.31, and this is what we have for the except clause. Now let's move on to the next section, and now we're gonna have the handler statement. So as you can see, this is the handler statement. This is the syntax handler, the name of the table, then open as alias handler, the name of the table, read, the index, all the stuff. So let's check out some examples. The handler statement provides direct access to table storage engine interfaces. It is available for database and MySQL tables. The handler open statement opens a table, making it accessible using subsequent handler read statements. This table object is not shared by other sessions and is not closed until the session calls handler. Close or the session terminates. If you open the table using an alias, further reference to the open table with other handler statement statements must use the alias rather than the table name. If you do not use an alias but open the table using a table name qualified by the database name, further references must use the unqualified table name. For example, for a table open using the mydb.mytable, further references must use my table. The first handler, and then with these three dots, that is ellipses, read syntax, fetches a row where the index specified satisfies the given values and the where condition is met. If you have a multiple column index, specify the index column values as a comma separated list. Either specify values for all the columns in the index or specify values for the leftmost prefix of the index columns. Suppose that an index my underscore IDX includes three columns, name, column underscore A, column underscore B, and column underscore C, in that order. The handler statement can specify values for all the three columns in the index or for the columns in a leftmost prefix. For example, we will do something like this: handler, then we would have some conditions, then read, and then my underscore IDX is assigned to, and then in the parentheses we will have column underscore A, column underscore A underscore value. The next would be column underscore B underscore value, and then column underscore C underscore value. Then we will have the handler read my underscore IDX, column underscore A underscore value, and the next one would be column underscore B underscore value. And finally we will have the same thing, and the only thing that is changing is that we will only have column underscore A underscore value instead of having the column underscore B and column underscore C. To employ the handler interface to refer to a table's primary key, use the quoted identifier primary inside of the backtick. So we have the handler, the name of our tables, and as we saw here in the previous example showing the table, this is all the tables that I have in my database name common queries. Okay, and then read, and then backticks primary. So the second handler read syntax fetches a row from the table in an index order that matches the where condition. The third handler read syntax fetches a row from the table in a natural row order that matches the where condition. It is faster than handler tbl underscore name read index underscore name when a full table scan is desired. Natural row order is the order in which rows are stored in my ascent table data file. This statement works for database tables as well, but there is no such concept because there is no separate data file. Without a limit clause, all forms of handler read fetch a single row if one is available. To return a specific number of rows, include a limit clause. It has the same syntax as for the select statement, so you can check out the select statement. We have the handler clause closes a table that was open with a handler open. There are several reasons to use the handler interface instead of normal select statements. Handler is faster than select. A design storage engine handler object is allocated for the handler open. The object is reused for subsequent handler statements for the table. It need not be reinitialized for each one. There is less parsing involved. There is no optimizer of query checking overhead. The handler interface does not have to provide a consistent look of the data. For example, dirty reads are permitted, so the storage engine can use optimizations that select does not normally permit. Handler makes it easier to port to MySQL application that use a low-level async-like interface, so you can check out this link for an alternative way to adapt application that use the key value store paradigm. Handler enables you to traverse a database in a manner that is difficult or even impossible to accomplish with select. The handler interface is a more natural way to look at data when working with applications that provide an interactive user interface to the database. So pretty much this is all the information. Handler is a somewhat low-level statement. For example, it does not provide consistency. That is, handler ellipses open does not take a snapshot of the table and does not log the table. This means that after a handler open statement is issued, table data can be modified by the current session or other sessions, and these modifications might be the only partially visible handler ellipses next or handler ellipses previous scans. And that's pretty much all we have for for the handler statement.